So laws of logarithms. Now, what is a logarithm? We talk about a logarithm is starts with an E and ends with an exponent. Yeah, a logarithm is an exponent. So remember way back at the beginning, we reviewed exponent laws, right? So how is that related? If logarithms have laws and logarithms are just exponents, then they should somehow be related to the exponent law. So let's take a look. So get your calculator out and calculate each of these. So log 2 plus log 18. Round it to the nearest hundredth. Okay, so if you know you're going to do like 5 things where you want to round to the hundredth, you can set your calculator to round for you. Okay, so I'm just going to clear this because it happens pretty fast. So if I go into mode, I say, look, we're doing like 6 of these calculations and I want them all to the hundredth. So that's on the float line, you go to 2. That says round 2 decimal places. Okay, we can quit out of that. Okay, and I'm going to go log 2 without the word log, without the log. So I'm going to go log 2. Now, you got to close the bracket, right? So it's log bracket, that's what your calculator is going to put out. You go 2, close bracket, plus log 18, plus log 18. And since we're done here, you can, if you like, close the bracket. If you don't, it'll throw one in, right? You just hit enter. So you want to be nice about it, close it, otherwise just hit enter. Okay, and then it's rounding for us. And then, now you can go second function enter, pull that line back down and just arrow over and put in a 3 and a 16. Or sorry, a 3 and a 12. So I can change that 8 to a 12, change that to a 3, hit enter. Okay, and then I want 4 and 9, so log 4 plus, and then make sure you're closing the parentheses, right? Log. Good. And then lastly, so what do you notice about all these values? They're all the same. They're the same. They're the same. How do the numbers in the first 4 expressions compare to 36? Now, what do you call it when you multiply 2 numbers together? What do you call what you get? The product. Right? Wish you knew that on the first step, right? So product. Product means to multiply. So what do you notice about the numbers used with their product? $36. All right, somehow we have to use the other there, right? We use there and there. In summary, the log base b of m times n is equal to, so the log of a product, I made sure it would match with your formula sheet. So, when you look at the formula sheet, you look at this, you can see the same thing. So in words, this just says the log of a product is equal to the sum of the individual logs. Okay, so here we were summing up these logs, right? But that's equal to the log of the product. Okay, so just taking one of these, right, we could say the log of 4 times 9 is equal to log 4 plus log 9. Okay, and it also works the other way around. So that formula works both ways. So we could also say log 4 plus log 9 is equal to the log of 4 times 9. Okay. So that formula works both ways. The log of a product, so if you're given a product, you can write it as the sum of any two numbers that multiply to give you that number. Or if you have the log of a sum, or sorry, the sum of individual logs, right, two different logs that you're adding together, you can write that as the log of the product. Called the product law. So what do we get when we multiply powers with the same base? What do we do with the exponents? Multiply powers with the same base, what do you do with the exponents? You add them. What's a log? It's an exponent, right? We're adding exponents. Okay, so it's related. The quotient law. Okay, we'll do these. Log 12 minus log 6. Log 12 bracket minus 0.30. Log 6 minus log 3. 0.3. What do you think log 10 minus log 5 is going to be? Log 10. So again, when you're working out a log, make sure that you're closing the parenthesis. Make sure that you actually type in the word log. So insert log. Okay. 0.3. And the log of 2 is? So what do we notice about the values you calculated above? They're all the same, right? We shall uncontract there. They are the same. What do you notice about the numbers used in the first 4 expressions compared to 2? I don't believe so. 12 minus 6 is not 2. Yeah. They don't subtract anything. They all divide to give you 2. What's the fancy word for the divide to give you? The quotient. The quotient. Their quotient. I had to throw that there. They are the same. So their quotient. Get rid of that. It's ridiculous. Nobody would say that. The quotient of each pair of numbers is 2. So the second law of logs, so the quotient law. The log of a quotient, right? So when you do division, you're going to get a quotient, is equal to the difference between the individual logs. Back to exponents. When you divide powers with the same base, what do you do with the exponents? So if I have 2 to the 8th over 2 to the 5th, what do I do with the exponents? You subtract. What are we doing here? We're subtracting. Logs. What are logs? Exponents. Now you don't have to memorize it. It's given to you exactly. And again, it works both ways, right? So you can go the log, and I'm just using a base 10 log here. So like the log of 12 over 6 is equal to log 12 minus log 6. So you give me a quotient, I can write it as the difference between two individual logs, or you give me the difference between two individual logs, log 8 minus log 4, and then I can write that as the log of, right? So mn, 8 over 4. That. The power law, which is actually the most powerful law, but we'll get to why over the next couple of days. Calculate the value of each expression using your calculator. So what is log 4 and what is 2 log 2? Clear. Log 4 is 0.60. 2 log 2 is 0.60. Log 8, 0.90. 3 log 2, 0.90. Log 16, okay. And you don't need to close the parentheses like when you're done. The last one, 4 log 2. You can if you like. Log 32, 1.51. And take a wild guess. What's 5 log 2 going to be? 1.51. What do you think we're going to say? They're the same. They are, well, contract. They're the same. What is the relationship between the number in the first log compared with the numbers in the second log? So how does 4 relate to 2 and 2? And if you come up with something like 4 is 2 plus 2, or 4 is 2 times 2, then try that thing out with 8 and 3 and 2. Or try that out with 16 and 4 and 2. Okay, so what's the relationship? Powers. The first number 2 squared. Okay, so then what's 8? 2 cubed. Okay, what's 16? So the number we're taking the log of gets raised to the power of the number that's out front, right? So here's the number out front. Here's the log that we're taking. So the log n times log base b of m, 4 times log 10 of 2 is the log of 2 to the 4th, right? 32 is 2 to the 5th. Again, this works both ways, right? So we say the log of 2 to the 5th is equal to 5 times the log of 2. Or if I have 3 times the log of 4, that is equal to the log of 4 cubed. Okay, so each of the logs, they're only listed one way, right? There's 3 of them. They're on your formula sheet. So the product, the quotient, and then the power. Okay, and they work both ways. You can go from left to right or right to left. Right? You can write this is equal to that, or that is equal to that. So the log of a power, 2 to the 5th, is take the exponent, right, out front, and it becomes 5 log 2. If there's a number out front, we can promote it up to be an exponent of the value there. It's going to come in real handy, but Not for what? So we've used inductive reasoning. Okay, so if you went through the 20.2, you used inductive and deductive. So inductive is we looked at a bunch of things and then we came up with a general rule. Based upon 4 or 5 examples, we came up with the general rule, right? Turns out those rules are true. To prove that, you have to use deductive reasoning, which says instead of using specific examples, right, do something more general. So if we want to prove more generally that the log of 12 plus the log of 2 is log 24, right, which is the product, right? It says the sum, if you're adding up individual logs, is the same as the log of the product, so 12 times 2. So if we say, let C equal log 12, right, you're not going to do anything with this. Okay? It's just a neat thing to see to show you how the log works. So if we say, if let C equal log 12 and D equal log 2, converting this to exponential form, right? So that's yesterday's stuff. The base is, what's the base of this? I don't see a number there. What's the base? 10, right? If you don't see a base for a log, it's base 10. So 10 to the power of C equals 12, right? Converting from log form to exponent. 10 to the power of D is equal to 2. Again, converting from log form to exponent. Now, we know that 12 times 2 is equal to 24. So 24 is 12, okay? But 12 is 10 to the C. Times 2, but 2 is 10 to the D, right? 2 is 10 to the D. 24 is 10, okay, exponent, laws, multiply powers with the same base, base of 10, you add the exponent. So 10 to the C plus D. This is exponential form. You want to change that to a log, it'll be log base 10 of the number 24 is equal to C plus D. Okay, log base 10. So a lot of logs is converting from exponential form to logarithmic or vice versa. But we know that C, right, we go right back up here, C is equal to log 12 and D is equal to log 2. So log 12 plus log 2 is log 24. Okay, so that proves it, and not by looking at what's log 12, right, it works out to this number, and what's log 2, it works out to this number. Right. We've done a more general proof of there is some number C, which is the log of 12, and then shown that, oh, log 12 plus log 2 is log 24. Again, you're not responsible for doing this at any point. All right, let's evaluate, using laws to evaluate logarithmic expressions. Okay, write as a single log. So we have the log of a sum. How do we write that then? It's the log of, or sorry, we have the sum of logs, and the sum of logs is equal to the log of the product, right? So 12 times 4, which will be log base 5 of 48. I wrote that too big. Let's do this. So the sum of logs is the log of the product. So when it says write it as a single log, okay, that means it's going to be log base something of one thing. Okay, so we don't have 2 logs, right? So initially we have log 5, log base 5 of 12 plus log base 5 of 4. We write that as a single log. Okay, if we are subtracting, what do? We divide. So it's the log base 7 of 8 divided by 2, which is 4. So it's the log base 7 of 4. Okay, try the last one, see what you get. What do we do when we add individual logs? We multiply, right, the number. So we change addition to multiplication. What do we do when we subtract? divide. So that's going to be the log base 3 of, okay, log base 3 of 10 plus log base 3 of 4 is the log base 3 of 10 times 4, right? We're adding, but then we're subtracting, so we divide by 5. So it is the log base 3 of 10 times 4, divide that whole thing by 5, which is 40 divided by 5, which is log base 3 of 8. Okay, and right now we don't know how to work that out. If I say what's log base 3 of 8, you would have to change it to exponential form, go 3 to the power of x is equal to 8, stick it in your calculator, graph 8, graph 3 to the x, find out what x is, right? So we're going to need a way, and we will come up with it. Write each expression as a single logarithm, then evaluate. That's interesting, right? Because we're going to end up with a base 6 log. So what's going to happen here? So we're adding. The sum of logs becomes the log of what? Okay? So it's the log of the product, right? So we change it to a single log. What's 2 times 18? 36. What does log base 6 of 36 say? It says 6 to the power of something is 36. Right? What's a logarithm? It's an exponent. What exponent? It's the exponent that we raise the base 6 to in order to get 36. So 6 to the what gives us 36? 2. So log base 6 of 36, you look at it and you say 6 to the power of something is 36. And wait, I can do that, right? It's 6 squared, so the exponent is 2. Log base 9 of what? What do we do? What operation? Division. We're going to divide. 162, right? So the first number is the numerator and the second number is the denominator. What's 162 divided by 2? So log base 9 of 81 says 9 to the what is 81? Answer is 2, right? 9 squared is 81. 9 to the power of 2. Log 25 plus log 4. So what does that become? To write it as a single log, it's the log of 25 times 4. So write it, take your time, one step at a time, right? You got to show work. So if you're on the diploma, you can't just jump. Okay, just show the work. It's the log of, right? I'm going to use the laws, right? The log of the product, 25 times 4, which is log of 100. What's the base? 10. So then it's 10 to the power of what gives you 100? 2. So the answer in 2 is A, B, and C is all 2, which is coincidence. Writing each expression as a single log without a coefficient. So get rid of the number in front. So what do we do with the number in front? Where does it go? Goes up as a power, right? So it becomes log base 5 of 12. Number out front goes up as a power, so it becomes the log base 5 of 12 squared. What is 12 squared? 144. So as a single expression, log base 5, 144. What is that? I don't know. We don't know how to work that out yet, but we'll learn. Between 3 and 4, right? Because 5 to the power of 1 is 5. 5 squared is 2. 5 cubed, right? That says what exponent? 5 to the what is 144. Well, 5 to the 3, 5 cubed is 125. 5 to the 4th is 625. So it's somewhere between 3 and 4. So we should have an idea when we're working stuff out. We should have an idea as to what a reasonable answer is. Okay, what do we do with the 3? Okay, comes to power, and 4 cubed is 64. So writing it as a single log, 3 with no coefficient, 3 times the log base 7 of 4 is the log base 7 of 4 cubed, or log base 7 of 64. Ln, well, ln and log, right? The laws apply. So what do we do with the 1/2? Okay, so we just write ln, 9, move the half opposite power. What's 9 to the 1/2? Okay, so an exponent of 1/2 means do what? Square root. Okay. And the square root of 9 is 3. Write each expression as a single log, then evaluate. So I got log 4, so I can't have 2 log 5. What do I have to do with that? Yeah, so we got to move the 5 up as a power. So here's the deal. The laws of logs work as long as there are no coefficients, right? You can't have any numbers in front. So we can't actually say, hey, you're adding 2 logs. We can't say that until we have the word log by itself, no number in front. So that's log base 4 plus the log of, so what's 5 squared? 25. Log 4 plus log 5 is the log of 4 times 25, which is the log of 100, which is 2. Also 2. All the answers are 2. That's what we got so far. Don't try that on the test. Log base 6 of 144 minus 2 log base 6 of 2. All right, give it a try. So you know what to do. So the first thing is you cannot do a log law, like plus or minus. You can't do that if there's a number in front. So your first step is, let's get rid of the number in front. So log base 6, 144 has no number in front. 2, so the 2 gets promoted, right? It moves from in front up into an exponent position on the value, whatever the value. And what's 2 squared? Minus log base 6 of 4. Okay, no coefficients now. What's the law of logs if I'm subtracting? Okay, we're going to change that into division. First number is the numerator, so it's the log of 144 over 4. Log base 6. What's 144 divided by 4? 36. So it's log base 6 of 36, which is 2. How surprised are we that the answer is 2? All right, let's just say equals 2. We're done. Move on. Maybe not.
I got 1.56.
Fascinating. How did you get 1.56?
I don't know. I just like answered my calculator.
Oh, well, it's because we figured out we don't know how to use our calculator yet to do this.
Oh.
So I wouldn't use it yet. Okay. So what we're doing is we're simplifying, right? We want to write it as a single log. What we're finding so far is that whatever the base is, the number that we're ending up with happens to be a power of that base. Okay. So then we don't need a calculator. Right? Because what we're asking here is 10 to the what gives me 100, 6 to the what gives me 36, and I don't know what we're going to ask here. Log base 4 of 8. What's the first thing we got to do? Got to move the 1/2 up to the exponent. Log base 4 of 64 to the 1/2. Okay, what's 64 to the power of a half? Okay, so what does the power of a half mean? Square root. So this says take the square root of 64, which is, I left the 8 out there. So we got log base 4 of 8 plus log base 4 of 8. Okay. Now what do? We've got the sum. Yeah, so we do log base 4. So the sum of individual logs becomes the log base 4 of the product, which is log base 4 of 64, which is not 2, 3. Right, so you say 4 to the power of what gives you 64, right? And if you're not sure, you just go into your calculator, go 4 squared, no, 4 cubed, yep. Simplify each expression, then evaluate rounding to 2 decimals. So you notice these are going to be base 10 logs or ln, right? Because those are the keys we have on the calculator. So right now, what are we going to do? Well, so instead of going log 8 plus log 5, we're going to do the log of 8 times 5, which is the log of 40, which is, turn that on, clear that, log 40, and close or not close, 1.60. There's rounding to 2 decimal places, right? So we're okay so far, right? We got that calculator set to round to 2. Okay, on a test or something, if you set your calculator to round, then as soon as you finish that question, just set it back over to float, right? Or you can get yourself in trouble, right? Especially if you end up doing a regression or something, your numbers will be off. Okay, what do we do with the 42 and the 2? Divide 42 by 2. So it's the log of 42 over 2. What's 42 divided by 2? Log of 21, which is, okay, 1.22? 32. 1.32. A little bit of work here. Ln 8 plus 3 ln 2. Okay, we can't use log laws or ln laws if we have a number in front. So what do? So we kick the 3 up as a power, right? So it becomes 2 to the power of 3. So the ln of 2 cubed minus ln 4. And taking our time, what is 2 cubed? 8. So ln 8 plus ln 8 minus ln 4. You said 9. Be ashamed of yourself. Okay, really, hang your head. Vow not to speak out loud for these other minutes. Embarrass yourself once again. Okay, YouTube. Nobody knows who he is.
Nobody knows.
Nobody knows. Worse yet, they don't care. What do we do with the plus? What do we do with the minus? Okay, so we're going to write that as the ln of, okay, the plus 8 times 8 minus, so divided by 4. What's 8 times 8 divided by 4? It's going to be 16. And what's the ln of 16? So we got our ln key, 2.77. And that's it. We're done.